So simplifying further, we'll get g of n equals 2 to the n minus 1 times our g of 1. G of 1, according to the base case, is that g of 1 is 2. So we know it's times 2 plus 2 to the power of n minus 1. So you can see this side, there is a pattern here. There's a formula for this particular one. Sum of, so you can see we have here, there is 2 exponents 0, 2 exponents 1, 2 exponents 2, this side. So there is a formula for this, and I'll first represent it in summation formula first. So plus we have our sigma notation. So 100 is multiplying sigma of 2 to the power of some I, where I starts from 0 and ends at n minus 1. That's the representation in summation notation. This is our argument, 2 exponents some I, and it's starting from I of 0, I equals 0. So 2 exponents 0 up till 2 exponents n minus 1, and we multiply it by 100. So this 100 will multiply it. So there is a formula for this. The formula is, so let's simplify. G of n is equal to 2 to the power of n minus 1 times 2. This is equal to 2 to the power of n, because we'll get 2 to the power of n divided by 2. We know that when we are subtracting, we divide, multiplied by 2. So these 2 will cancel. That's leaving us with 2 exponents n. Okay, so plus, now 100 times this, there's a formula for it, so I'll quickly write the formula down. So we have 100 times, so a times 2 exponents the number of terms minus, sorry, is it r exponents the number of terms minus 1, a multiplying r exponents the number of terms minus 1 all over r minus 1. This is the formula. So where a is our first term, a equals first term, r equals the common ratio, yeah, and the number of terms at the top there. So we get g of n is equal to 2 to the power of n plus this 100 times, and you see a is equal to 1. Our first term is 1. From this we can see that it's actually going backwards, so you can see it's, let me see, so let me write 2 exponents 1 and 2 exponents 0. So it's actually starting from here, 0, 1, 2. It's going like that, 3, 4 onwards. So this is our first term, 2 exponents 0, which is 1. So a equals 1, and our common ratio is 2, because you can do this, represent this by 4. That's 2 exponents 2 divided by 2 exponents 1. You get 2 as the common ratio. Next term minus the previous term, divided by the previous term. So you get r2 as 2. Okay, so let's put them in the equation. So we get our 1. I'll omit that to make it clean. So we have our 2 exponents the number of terms. The number of terms here is n minus 1. So our n minus 1 and what's minus 1 all over 2 minus 1, r minus 1. Okay, let's copy it down. 2 to the power of n plus 100 times, now we have what, this goes out, 2 minus 1 becomes 1. Any number divided by 1 is the number on top. So we have what, times 2 exponents n minus 1 minus 1. We go on to simplify to get 2 exponents n plus 100. 100 is multiplying both of them. 100 times 2 exponents n minus 1 minus 100. So now let's simplify further. So g of n is equal to 2 exponents n plus, we can simplify this by making it, finding a multiple of 2. So 50 times 2 times 2 times 2 exponents n minus 1 minus 100. So why did we even do this? It's just to get the 2 exponents n, because as I did at the top here, 2 multiplying 2 exponents n minus 1. N minus 1 is the same as 2 exponents n out all over 2. And multiplying it by 2, we cancel out to get our 2 exponents n. So let's do that. G of n is equal to 2 to the power of n plus 50 times 2 to the power of n. Okay, minus 100. So we get g of n is equal to, now we can still simplify further by bringing 2 exponents n out. So let's factorize 2 exponents n. So here will be 1 plus 50 or minus 100. Now g of n is equal to 2 to the power of n times 51 minus 100. This is the end. So this is the number of goats that will be at there at the start of the nth year.